So in this example, we're going to find the maximum and minimums of a quadratic function, but this is more of an application problem. So the question reads, the total revenue R earned per day in dollars from a babysitting service is given by the function RP is equal to negative 12p squared plus 150p, where p is the price charges per child in dollars. Okay, so the first part of the question tells us simply to find the revenues when the price per child are $4, $6, and $8. What this requires is for us to evaluate our revenue function at p is equal to 4, p is equal to 6, and p is equal to 8. So what we have is that r of 4 is equal to negative 12 times 4 squared plus 150 times 4. So that's negative 12 times, now 4 squared is 16, plus 150 times 4. So then this gives us negative 192 plus 600, and that simplifies to be positive $408. We do the exact same thing again to find the revenue when P is $6. So this is negative 12 times 6 squared plus 150 times 6, which gives us negative 12 times 36 plus 150 times 6. Now the negative 12 times 36 gives us negative 432 plus, and 150 times 6 is 900. So then we get a total revenue of $468. And the last one, we'll move it up here. Our revenue when the price per child is $8 is equal to negative 12 times 8 squared plus 150 times 8, which is negative 12 times 64. Plus 150 times 8. So then we get negative 768 plus 1200, which gives us a total revenue of $432. So one thing we can notice is that the revenue when the price per child is $8 now has gone down because the total revenue is $432 versus when the price per child was $6. We had a revenue of $468. So it looks like the more it costs per child, maybe not as many people are using this babysitting service. So it's going to be of interest, what should we be charging per child to maximize our revenue? And because this is a parabola, and our coefficient is negative 12, we know that we're going to open down, so we will have a maximum value. So now let's go ahead and write some of that down for part B. So part B, our revenue is given by negative 12p squared plus 150p. So in this function, we see that our coefficient A is equal to negative 12 and B is equal to 150. So our formula for our vertex tells us that our maximum value is going to occur. Our max will occur at x is equal to negative b over 2a. So that's going to be negative 150 over 2 times negative 12. So then we get negative 150 over negative 24. And that just simplifies to be 25 over 4, which is $6.25. So when we charge $6.25, that's going to give us our maximum revenue. Now, what is that maximum revenue? The way we find our revenue is we evaluate our function at the 25 over 4. So our max revenue is R of 25 over 4, which is equal to, now when we plug in 25 over 4 into our revenue, we get negative 12 times 25 over 4 squared plus 150 times 25 over 4. And this gives us negative 12 times 625 over 16 plus 3,750 over 4. And then that gives us 1,875 over 4, which simplifies to be $468.75. So our maximum revenue is $468.75, and this occurs when we charge $6.25 per child.